Alright, so welcome back again. My name is Jesse, and in this wonderful and exciting tutorial, we're trying to see some various tools we can use to do online machine learning or incremental machine learning. So the traditional machine learning that we know about is what is called offline machine learning, right, or batch machine learning. So in that case, you have a batch, data in batch, right, data that is already at rest, and then you learn from it, and then you build your model, then you make your prediction, then you productionize. But there's another concept which is called online machine learning, in which you do machine learning on streaming data, right? So a simple illustration is that by what we already know, the traditional machine learning, which is offline machine learning, that you have some data, right? Then you split the data into training, testing, you do feature engineering, you build your model, then you deploy it, right, into production. That is a traditional offline machine learning, right? So the concept of offline machine learning or batch learning is that you already have your data at rest. You already have all the data that you need is already there, right? The data is at rest, and you have all the data in batch, right? Then you learn from that particular data, you train your model from that data, you build your model, then you deploy it into production, right? But in case you have data that is in motion, data that is not all at rest, that is coming one at a time, and you want to do machine learning on it, that concept is called online machine learning, right? So the data is coming in bits, it is coming in streams, right? In streams of data, one at a time, one phase at a time, like this, right? So you have to do ML on this particular data, you do prediction, another one come, you do prediction, another one come, you do prediction, right? Or you train it. So this concept of doing machine learning on streaming data or data in motion is what is called incremental machine learning, right? So it is very useful. It's a very useful concept in case you want to build a recommendation system that you don't know anything about the user, and you want to build something off on the spot to help make some prediction. Okay, so let's go back and see how to implement these things, some of the tools you can use to do online incremental machine learning. So the ones for offline, everybody knows scikit-learn, Python, TensorFlow. Although they are useful for offline, they can also have some techniques you can also use for online, right? Okay, so let's go back again and check it out. So to recap, offline machine learning means that you have a bunch of data, and then the data is at rest, then you are going to learn from it and then make predictions. Online is that you have data that is coming in streams or data that is in motion, then you are doing machine learning on it, like real-time data, right? One observation at a time. So the advantage of the online is that it's very useful in case you don't know anything about the person, and it's adaptive, so it's very useful. So the tool that we can use for doing incremental machine learning, right, or online machine learning is we have River. So River is a nice Python library, which is like the scikit-learn for online machine learning, or the scikit-learn for data in motion machine learning, which is a combination of creme, right? Creme is coming from the name increment, right? Creme, and then scikit-multiflow, which is also useful for working on streaming data. So they combine creme and then scikit-multiflow to produce River, right? So this API is the same, right? For this one, the two of them, the API is very similar. Okay, there are also some other non-Python packages like Moa, and you also have StreamDB for working with PySpark or Spark, Apache Spark streaming data, right? Which is very useful, right? So these are some of the packages you can use to do online incremental machine learning. Okay, so it is very useful. So these packages are useful in case you want to do online ML, in case you want to do ML on streaming data, as well as to identify concept drift, model drifting. There are some wonderful packages in these two packages that allows you to be able to identify and detect drift in your model. Okay, the challenges of using these particular models is that like it can be difficult to manage because they are highly adaptive, unlike the offline. Once you have finished everything, you deploy them, you manage it like that, right? If the models lose their performance, if the model decay, you can gather new data, retrain, and then bring out a canary model, right? So that you just take off the challenger, or the challenger and the canary model, which is a different concept later when we talk about it. Okay, so let's install these particular packages. So to install it, just go with pip install River to install the package, or pip install creme, another package, and then pip install scikit-learn. So any of them can be used for online incremental machine learning. So let's start with the first one, working with River. I'm going to import pandas, right? And then let's import the package. I'm going to load in our ML package. We're going to be import River. So check with River first, then later on you check on increment. So with River, there are a lot of things you can do. Let's explore the particular package itself. What are the methods of this particular library? Methods, so dir and then River. So if I check it out, you can see that we have all of these things there, right? We have a sub model for anomaly detection, for working with clusters, for building pipelines, for data sets, for model for checking drift, ensemble techniques, evaluation of the model, feature extraction. You can see most of these scikit-learn models there, right? Linear model, almost the same API, right? Metrics, neighbors, naive base, and the rest, right? Okay, so I want to be able to get all the various things that it supports. So I just created a simple function, which is this particular function, right? So the API is just like scikit-learn. So in case you are using scikit-learn, just change this one from scikit-learn, right? If it was like this, just change it to River, right? Because the API is almost the same, right? Perfect. That is how to do that. So you can just go it from River dot linear model, import logistic regression, right? Or multinomial from naive base, and then feature extraction. You have bag of words. We don't have count vectorizer. We have bag of words and you have TF-ID. So in case I want to explore all the various sub models, I have created a simple function to help us with that. So the same thing we did here with the DRL, that we got all of these things. I've converted them into a simple function that loops through the entire stuff, right? You can use this particular function. It's going to loop through the package itself, take out these ones because these are not sub models, and then it's going to get the remaining one and append them and produce our model, right? And produce a data frame with all the various sub models, right? You can use it for any package that you want. The only thing you have to change is that you have to change this one here, right? That is the only thing. You just change the name of the package. Okay, so let's move on and work on it. So it's going to be my River df, right? It's going to be my get all attributes for the package called River. So in case you have any question or contribution, you can just put at the comment section below. Apologies for the noise you may hear behind. Let's check it out. So if I go back and I check it out, you can see that these are all the various sub models, right? About 33 of them. We have anomaly detection, right? For everything, in case you want to do anomaly detection, the base, you have classifiers, drift detector, all the clusters, k-means, in case you want to do k-means on streaming data. We have stream k-means also. In case you also want to do, you see that there's pipeline, in case you want to build pipelines, it's like scikit-learn, transformer union, like scikit-learn. These are all the data sets that it has. You can also do some detection for drift using admin, a very powerful, popular algorithm for detecting drift in models, as concept drift. And then we also have for the ensemble methods, we have combining admin for other boost, all the different classifiers, boosting algorithms. We also have for the evaluation, right? You also have for the optimization, and then there are lots of things, right? In case you also want to do some test processing or just transformer processing, we have all the transformers, binarizer, LDA, minimax, scalar, normalizer. So everything like scikit-learn is already there, right? So this is a simple function to help you get that. Now, too much of the talking. Let's see this particular code. So the caveat, right? The requirement for working with this particular package is that the data set must be in a format of, as I said, the data is coming in streams one at a time, right? So this is going to be the requirement. So the data must come in streams in batch. So you can also use, so in most of the case, you can just use a dictionary, or you can just use a tuple, right? A tuple of, in case you want to train it, right? A tuple, a list of tuples, something like that, right? Something like that. Or you can use a dictionary, right? Or you can also use CSV, right? But in using CSV, you have to format it to be in this particular format, either in a list of tuples or a dictionary of records, right? So that is one of them. There's also ITA, CSV, and then ITA pandas, right? That you can also iterate through a CSV or a pandas file, right? In case you're working with CSV. So let's see the simplest approach, right? The most simplest approach. So our task here is that we want to predict if a test is hardware or software. So we have our test here, right? And then we have the label. So my unit test field is software issue. Try the program, that is software, right? So we have just built a simple data. This is going to be our training data or our main data, right? Very simple, not a lot of them. And also have one for the testing, right? Simple like that, right? So let's check it out. So that's going to be our test classification. So as we already know, in test classification, we have to convert our test into numbers, right? So you have to vectorize them. So you can use count vectorizer, but there's no count vectorizer transformer, there's bag of voice, which is the same approach. Then you also have TF-ID. So this is useful in building the model on the go. So let's check it out. So I'll come back again, and then let's build our model. So I have to first of all import. We have already imported TF-IDF from above, bag of voice. So let's use bag of voice and then multinomial. We need to build it like a pipeline, right? So let's build a pipeline to make our work easy. So in case you want to learn more about pipelines and some extra things with machine learning, you can check the links below for more. Okay, so let's check it out. So I want to put my pipeline to from river.compose import pipeline, right? That is a package, and then now I can just build my pipeline. So let's go to pipe for naive based model. That's what I built. Then I'm just going to go with my pipeline, and the pipeline takes a tuple of tuple, right, for the steps. So the first one is going to be my vectorizer. So let's go as my vectorizer, right? And I'll pass in my bag of voice. So I want to get everything as lowercase, so that because it's bag of voice. So let's set as true, right? Perfect. And I also want to put in my model, so I can call it as my naive based model. Then I'll put in multinomial. So multinomial naive base is useful because you are working with test data, and then we are talking about the frequency, right? That's why we use multinomial. Okay, perfect. So that is going to be the simple model for us. And one nice thing about this wonderful package is that you can visualize the pipeline. You can want to see the pipeline that I built, right? Scikit-length, you can also do that. In case you want to learn about that, you can check the links below. Just go with pipe NB, and it's going to visualize it for you. So this is how it is. So if I click on it, it's going to give me all the various things. So in case you have a lot of hyperparameters and some tweaks, you're also going to see them here. If I click on this, you can also get that one out, right? Which is very cool, right? So it is very cool. Out of the box, you can visualize your pipeline. Perfect. In case I want to check for the steps inside this particular pipeline, so pipe nb.steps. So this is going to list all the steps for us in an ordered dictionary. So we have my vectorizer here with the bag of words and all the parameters, and then my naive base model, and then all the parameters. Very simple. Now let's build our model, right? Let's fit on our data. So the concept here is that we are going to learn one at a time. That is a big understanding because it is streaming data, right? You are simulating streaming data. So in this particular package, we just go with learn one, right? Or learn one, right? Everything is, or we have predict one, right? So because we are doing it one at a time, that's the basic understanding behind it. So let's go with it and go with option. So I have my data here. So for x, we can call that for my x, or let's call that for my test, and my label in my data dictionary. I want to print it out. So print my test and get all the tests from this particular data set, right? Which is the first part of the tuple, right? Then the second part is the class or the label, right? So we are learning one at a time. We are fitting it one at a time. So in case I want to get the label, right? I'm going to get the label. Perfect. Now let's build our model, right? So I'm going to learn from it. It's going to be my model. So pipe naive base model. And I'm going to pass in my option. So naive base dot learn one. In river, it is learn, right? Learn one. In creme, which you'll be learning later, it is fit one. So this one is for creme, right? This one is for creme, but for river, it is this. That is the difference, right? The same API, but that's the difference between the river and then the creme, right? Very simple. Learn one, and I'll pass in my test and then the label. That is all, right? So the data is going to come in one at a time. That's finished. Now that's finished building the model. If I check it out, you have my model already built, and I can actually use this particular model that I built to make some prediction, right? Very simple. So let's make some simple prediction with what we have so far. I want to make a prediction, right? And I can just go back and specify that pipe NB. As I said, this is one at a time. So predict one. You can also do it predict many, but that's one you have to supply a data frame, right? Okay, so I'll just pass in here and say that, okay, something like I built an API, right? So this is going to be a software issue, right? Because because it's software. So it's very simple, right? Just that small amount of data it was able to give me. I don't even need to encode it. It was able to identify it. Now let's make another prediction. Right, I'm going to make another prediction. So let's say same thing, pipe naive base dot predict 1. Then I'll pass in, let's say this one I built an API, so let's say the hard drive is damaged, right? Let's see whether it's going to give us it's damaged software. It's also software, right? So sometimes it will give you some wrong information, right? That's what I was saying. Like, so you have to make sure that so let's make the hard drive in the computer is damaged. So this is still given. That's one. So it learns over time. So you have to, after learning it, sometimes you have to update your model over and again, right? That is the basic understanding behind it. Perfect. So let's come back again. So in case I want to check for the accuracy of this particular model, right? This simple one we have built, you have just learned, right? We have not updated, you have just learned the previous one. I want to check for the accuracy of this model. I can also use the test data set. I want to evaluate the model and get what classification reports. So I want to know the accuracy of the model. I want to know what the precision, and then the F1 score, the recall on the prediction at the go, right? Can also do that. So this thing that we did, this predict one that we did, we can also get the probability of it, right? In case I want to get the prediction probability, right? And this is very useful. Probability. Prediction proba. Let's go the same thing we did and just change it to a what? Predict. Right, so we have predict many in case you have a data frame. We have predict proba many, we have predict proba 1, right? So I can run it again and then it's going to give me the probability. You can see that the probability for the hardware is 42 and for the software is this, right? I can also do the same thing for the other one, which was this option here. Let's paste it under it. So I want to get the probability for this one. Proba 1. Let's check it out. See that this is high, right? This is very high as compared to this one. This is low, but this one is almost half. So it must learn more to adapt to understand the patterns, unlike the traditional batch learning offline mode, which could have been more accurate, right, and more precise. But this is faster, as you can see. Okay, so let's get the classification report, the accuracy of the model. There are several ways you can do that, but let's use the simpler ones. So I have my data here. My test data we already have, right? We had our test data here, which was this one. I want to use this test data to make some predictions. I'm going to apply the same model on these 4 predictions and get the result. And then when I get the result, I'm going to use it to do my prediction, right? So just as we always do, we have the Y predict and then the Y test, right? So let's get the Y test. Right, so let's call this one as my Y predict first, right? I'm going to create a tuple, a list. It's going to be this option. So for I in my test data, right? I want to make some prediction from this, right? So I can just go with the same option. So I want to just pick only these ones, right? So in case I want to pick only this one, I can just go back with this option. So this, we can unpack them, right, to help us make our work. So let's see, and J, right? I and J. We can just make the same thing, X and Y. X and then Y, right? I want to get only the test. I can just go with print S, right? So this is going to give me only the S. Now I want to use only the S to do the prediction. So now I just come back again and predict it out. So it's going to be my pipe dot naive base dot predict 1. I'm passing my S, right? So this is going to give us the prediction of that particular one. So let's print it out. Let's print out the prediction. I see that it's giving us the result, right? So this one was what? Write code daily. It was software here. This is 40. This is hardware, but this one said it was software. Refactor the code was what? Software. It predicted as software. No empty space on the drive. This hardware, right? Very cool. So it's able to make a good prediction, right? Now let's append the result here, right? So I have to append the result into my option. It's going to be append. So let's put as result. Then I'll append the result here. So Y predict, but append the result, right? Perfect. Now we have finished building our model. Now in case I want to get the classification report, you have to import it. So it's going to be import or from river, as you'd have done it, scikit-multiflow.metrics, import classification report. This is capital, not small letter. Perfect. And now I can just create a report, and then you can just get the accuracy. So report, go to my classification report, right? I'm going to create an instance of it, and now we can update our model. So we already have our y predict here. I want to get the y test. So in case I want to get the y true other, right? The true stuff, which in that case is going to be my y test. Same thing. So in that case, it's going to be the data that we had here. So for x and y in test data, right? We can actually make it simple for us, right? Instead of writing this one, we can just do the same thing that we did. So we can just copy this one. Let me copy it to save us time. There's another way you can also do that. I'm making it as simple as possible, right? And this is going to be my y test. Perfect, right? So we have the y predict and then the y test. So now I'm just going to go back again, right? And I'm just going to append for the y. So y test dot append. I'm passing my y. Perfect. That's finished doing everything. Now let's check it out. If I go with my y test, it is perfect, right? I've gotten our result. And if I check it with the print y test, this is the one we're supposed to get, and then print for the y prediction for that particular test. Let's check it and see. So if you check it out, you can see that we have software it was able to predict it right, but this one did not predict it right. So it got 1, 2, 3 correct, but 1 it failed, right? So you can actually do the report for that. So let's loop through it and get the report. So it's going to be for y true and y predict in, let's zip them out. So zip my y test, my y predict. I can just go back again and go with my report, passing my report dot update. So this is going to update it and then give us our result. I'm going to update the y true, y predict. Perfect. And now I can just check for the classification and the accuracy. So report. I did all of these things to make it easy for you to know the precision, right? You can see that the precision for the hardware was 1, right? And then recall was 0.5. As you can see, it made a mistake here. Any place is so hardware, it was able to give it precisely, but it failed. It failed at a particular place, right? For the software, it's able to give us something, but it failed in some of them, right? That is the basic understanding behind it. So it's able to give us the classification report, the precision, recall, and then the F1 score for that particular prediction, because this is doing it online, right? In batches, right? Or not in batches, in mini batches or in streams. And this was the accuracy of our model. So that's how to work with this wonderful package called River, right? So in the next session, I'm trying to see how to do the same thing with Creme. So to recap, you can just go straight away with this option. Just go it from river.compose import pipeline. We are vectorizing our test using bag of voice or count vectorizer. We are using an based multinomial model. We created a pipeline, then we fit our data set one at a time, right? So after doing this, we can actually update the model, right? And then it's going to be performance. So it's going to be something like this. So I'll copy this one, and then we can update it. This is how to learn, and this is how to predict. You can also get the prediction probability for that particular prediction, and you have seen how to also get the accuracy of it using the classification report. It supports accuracy score and all of these things, but this is a simple way because I feel this one is going to give me the precision and the recall at that time. I can also get another way, update the model using this approach. So let me put it here. Okay, another way you can also check for the metrics of the accuracy of it is that you have to update the model and then you check it, right? So you can also use the test data, right? Just as we did above, we are looping through them. Then we are going to learn at the last page. This is going to be the last thing, right? So whatever is going to learn, right, we will now make a right prediction before, right, and then you update our model, right? That's a big understanding. So let's run it again. It's giving us an error. So the reason for the error is because we spelled it wrong. It's metrics. Perfect. Now I can check for the accuracy of it, and let's check it out. It's another way. So metric is 75%, which is the same thing that we had here, right? Very simple. So that is how to update the model and then check for accuracy, right? Notice that we are not using the main data, because if I use the main data here, it's going to give us 100%. If I go back and I use the main data, right? So let's bring this one here. It's going to give us 100%, which is not what we want. We want to check for how accurate the model is. So to check for how accurate the model is, use the test data, which was the data that we use for the classification report. This particular data here, right? This data that we use for the classification report, the same thing. This is the same concept, but this one, the classification report here, is giving us more information together with accuracy, and this approach gives you only the accuracy, right? Because you're just importing accuracy from the metrics, then they're using it on the test data, not right. So update data on the test data so that you don't confuse, right? So in that case, because you are doing that, this has already been learned. This is right. So this particular one has already been done already, right? So that's why it's the last one, and these are the new ones that are being coming. So it's going to, this is already done already, right? And then this is going to predict again, get the result, put it aside here. It did the same thing that we did above, and then give us the result, right? So this is going to be our metrics, as you see. But if I check this one on the main data itself, right, it's going to give us 100%, which is not what I want. So let's make it like 2, 2, 2, right? If I run this one, it's supposed to be this option. I made a mistake here. If I check it out, this is going to be almost 100%, right? Because we are trying it on the main data. It's 100%, right? So because we are trying it on the test, on the train, right? So let's go just. So this is supposed to be 100% because we are just testing it on itself. So it's giving us 100. But to get the accuracy, you just test it on the test data, right? That is the basic understanding. So thank you for watching this tutorial. In case you have any question or contribution, you can just put it in the comment section below. So maybe in another time we'll try and see how to use this one to build a very simple app with Streamlit. See you in the next session. Stay blessed, and don't forget to check the links below for more. Bye.